Now, as you know, a process generally have two types of tasks. One is the burst time, which means it uses CPU for most of the time, and then at any point in time a process will want to do IO. IO means it want to read something or it want to write something, right? And most of the times IO will be done from the hard disk. So hard disk means the secondary memory. So any process generally will have, one is a need for CPU time, and second thing is a need for IO. Now if you generally schedule a process, it will go to the CPU and start executing, and the CPU will be very fast, that it will be finishing its burst time very quickly, and as and when a process requires an IO, it is going to block it, right? Therefore your process is going to get blocked whenever it needs the IO, let's say hard disk. Now what happens is, gradually as the time goes on, many processes will need the IO, and since the hard disk is very slow, the requests will pile up at the hard disk. Now at a hard disk, the queue of waiting systems or the queue of waiting process which require to read some data from the hard disk or to write some data into the hard disk are going to pile up. Now the main issue here is, how are you going to process the requests? The reason why I am saying this is, the order in which you process the request is important. Is now, depending on the way you service a request, the overall time taken by the hard disk to process all the requests is going to vary. For example, if you want to, if a process wants, let us say, track number, let us say sector number 10, a process wants it. Now if you are going to provide it with sector number 10, and next if any other process wants sector number 11, if you provide the service to that particular process, you will not be wasting any time. Otherwise, let us say there is 10 in one track and 100 in other track. Now if you have to move the read write disk from the track containing 10 to track containing 100, it is going to take some time. Therefore, based on the way you service the requests, the overall time taken by the hard disk to service all the requests is going to change. Now the main purpose of the operating system here, whenever operating system comes into picture here, its main purpose here is to see that it does all these requests in an optimum way. Optimum way means reduce the time as much as possible. Now when you go to the hard disk, there are various times. We have seen it in CO also, we have seen it, that there is something called as seek time. Seek time is moving the read write head to the appropriate cylinder or the track is called as seek time, right? In case if you have many disks, then we call it as a cylinder, right? If you have only one disk, we call it as a track. Now if you have to move the read write head, there is going to be seek time involved. Now if you have to decrease the seek time, then you better process or provide service to all the processes which have all these requests in a closer proximity, which means let us say one process requires some data from cylinder 1 and other process requires from cylinder 2. Better you do it one after the other. Instead of going from cylinder 1 to cylinder 100, go from 1 to 2. That is how you are going to save some time, right? So your operating system has to look into all these details. Yes, one thing is for sure, hard disks are going to be very slow. The reason is the basic bandwidth or the rate at which you can read the by reducing the seek time, right? Now how we reduce the seek time, that depends on the algorithms which operating system is going to use in order to provide the service, right? So let's see all the algorithms one by one, and we shall see with examples that once we go with some algorithm, the time taken will be something, and if you go with some other algorithm, the time taken will be some other thing, right? So let's see this part. This is called as disk scheduling. So what is disk scheduling is, if there is a hard disk and a queue of requests waiting to be served, then which request you are going to serve next, that is called as disk scheduling. Okay, now let me read it out for you, the theory. File systems must be accessed in an efficient manner, especially with hard disks, which are slowest part of the computer. So as you know, every file is going to be stored on the hard disk, and hard disk is the slowest part of the computer, and so you have to do the access in an efficient manner. As a computer deals with multiple processes over a period of time, a list of requests to access the disk build up. For efficiency purposes, all the requests from all the process are aggregated together. So whenever all the process are getting blocked in order to get the service from the hard disk, all of them will be in a queue, right? Now all of them have to be considered together, and you have to decide about which one you should process next, right? That is called as aggregation here, right? So all the requests are considered together, and you are going to provide the access to all of them at once, right? Now the technique that the operating system uses to determine which request to satisfy next is called as disk scheduling. So the technique is nothing but the algorithm which we are going to use. So there are various techniques which operating system can use in order to provide the service to the next process. We shall see each one by one. Okay, fine.